Welcome back, mathematical scholars. We've just learned about the law of sines, so the next natural progression would be, hey, let's learn about the law of cosines. So with the law of cosines, you're going to see two formulas, but they're the exact same formula that's just been manipulated. You can use one of those formulas to find a side, that's what we'll do first, and you can use the other formula to find an angle. That's what we'll do on the next page. So it depends on what's given to you in the problem, and that will determine which formula you end up using. So if you're given side, angle, side, so if you're given a side, the included angle, and another side, if you're given those three things, then you can use this formula to find the third side. So once again, if you're given two sides and the angle that's smushed in between them, then you can use the law of cosines to find the third side. So let's go ahead and do that. For the first example here, we're going to use the law of cosines to find the missing length. That's going to be this one over here. And then we're going to use the law of sines afterwards to help us find the other angles. So we have side, angle, side. We're given this side. We're given the angle in between, and we're given this side. So we see side, angle, side here. So we're going to be using this formula. The key thing to remember is, if this is the angle that I'm looking at, think of that as like your reference angle, the A and the B are going to be the two sides that come off of that angle. So this can be A and this can be B. It doesn't really matter which one you choose as A or B. You'll get the same answer anyways. It's kind of like the Pythagorean theorem where you could determine either leg was A or B. The only thing that really mattered was C was the hypotenuse. This is kind of the same in this formula. The C has to be the side opposite of the angle that you're looking at. So let's just go ahead and plug these numbers into the formula. We're going to have C squared. We don't know what C is, so we're just going to leave it as C. Equals 55 squared plus 38 squared minus 2 times your A, that's again 55, times your B, that's going to be your 38, and then times cosine of 62 degrees. So that's a really long, messy, drawn-out equation. You can just type this in exactly as you see it into a calculator. Once again, make sure that you're in degree mode if you're using Desmos or any other calculator. And if you type all of that in a calculator, you're going to end up with C squared equals about 2,506.6. So maybe pause the video and double check, make sure that you know how to type it in the calculator correctly. But we know that this side here isn't going to be 2,506 because, you know, the other ones are only in the 50s and 30s. To get C, we still have to square root it. So we're going to square root both sides, and we get a C value of 50.1. It's always a good idea, well, if you want to put units, you can. It's always a good idea to check the reasonableness of your answer, and you'll notice, you know, if this one over here looks like 55, yes, it seems like that would be pretty reasonable that that one would be about 50.1 centimeters. So seems like we have a pretty reasonable answer. So let's go ahead and label this one now. This one we now know is 50.1. Now that we have that, you'll notice we have one of those pairs, and we can use that pair to end up with the law of sines, and we can use it to find another angle. So let's now go ahead and find another angle. So you can choose either one that you want. I'm going to choose to find this angle. So we're going to use this pair, and we're going to use it to help us find this angle in that other pair. So we're going to have, again, the variable will be on top. So I'm going to have the sine of x matches with 38, the same way that the sine of 62 matches with 50.1. So we're setting those pairs equal to each other. To solve this one, you just multiply both sides by 38. And that goes away. If you take that entire right side and you multiply those and simplify them together, we end up with sine of x is equal to 0.6697. Again, if you're unsure, make sure you pause that video and make sure you understand how to use that calculator properly. And at the very end, in order to solve this one, we have to do inverse sine to get rid of a sine. So we're going to do inverse sine of 0.6697, and that's going to give us an angle of 42 degrees. So we've now found that this angle here is 42 degrees. And lastly, there is a third angle. This last one, you don't have to do anything fancy. No law of sines, no law of cosines. Just remember, all the angles in a triangle add up to 180. So if you want to find this angle, we can just subtract the two angles that we already have. So the 42 and the 62, that accounts for 104 degrees, which if you subtract it from 180, we're left with 76 degrees for that last angle. So there's a little introduction to the law of cosines. We used it to find a side. Once we had that side, then we used law of sines to find the other missing angles. Go ahead and try the next one on your own and pause that video right now, and then when you are all done, come on back. You didn't pause it yet, did you? You're just waiting for me to give you the answer. Pause. Welcome back. I hope that wasn't too stressful for you. Hopefully, if you did everything correctly, this was your angle, and then your A and your B came off of that angle. So we had 12.6 as your A, 6.8 as your B, or you could switch those around. It didn't matter. Either way that you did it, you should have ended up seeing C squared equals 334.3. And when you square root it, we got a final value of 18.3 centimeters as our missing length. Now, you might have gone ahead and done the rest of them. I'm not going to show that because this is a video of the law of cosines, not the law of sines, but this one I think should have been about 14 degrees, give or take a decimal point there. And the last one should have been, I believe, 27 degrees. So if you went through everything and found 14 and 27, great. You know what you're doing there. Now we're going to move on to the other type of formula. And this is if you are given all three of the sides. So if you're given three sides of a triangle, but now you're not given any of the angles, you can use the law of cosines to find any of the angles. So you could find this one. You could actually find this one if you want. You could find this one. It doesn't matter which one. Just pick one and find it. And in order to do that, you're going to be using this formula here. Cosine of C equals that big mess. Again, the key thing to remember is whichever angle you're looking for, let's say you're looking for this angle, the two sides that come off of it, that's your A and that's your B. So this would be A and that's B. And then C is the one opposite of the angle that you choose. So let's go ahead and do the first example here. It says use the law of cosines to find the missing angle in the triangle below, and then find the other two angles using any method you want. You can choose to use law of sines or cosines. So if this is the angle that I want, then I'm going to determine that my A and B are going to be these two sides that come off of it. It might help to label those. We can label this as A and this is B, which then makes this side C, just for now. If I had chosen to find that angle, your A, B, and C, they're going to switch around a little bit. So just for now, I'm labeling these A, B, and C. And let's go ahead and replace them into the formula. So we have cosine of angle C is equal to 22.9 squared plus 14.7 squared, subtract 30.2 squared, and that all gets divided by 2 times 22.9 times 14.7. Now be really careful about how you type this into the calculator. If you just type it in the way that I just said it, 22.9 squared plus 14.7 squared minus 30.2 squared divided by 2 times 22.9, that times would end up going on the top, and we don't want that to happen. So it might be a good idea to put parentheses around this and then also parentheses around this when you're typing it in, if you're doing it on like a graphing calculator. If you do it on Desmos, you can make it appear kind of the way it looks on the screen, and it's a little more user-friendly. So make sure you're able to do that, and if you do it correctly, you should end up with cosine of c equals negative 0.25479. And to get rid of cosine, remember we're just looking for c. To get rid of cosine, you have to do inverse cosine. And so we take inverse cosine of negative 0.25479. And that equals about 104.76 degrees. And for our purposes, let's just round it to 105 degrees. So we just found that this angle here is 105 degrees. So I'll let that sink in for a little bit. So now that we've found that angle, we now have to find the other two angles using whatever method you want. You'll notice we now have a pair. So we could use the law of sines, but this is a video on law of cosines, so let's go ahead and use law of cosines. So now what I'm going to do is I'm going to find, let's just find this angle over here. I'll use a different color. I'm going to find this angle. If I want to find this angle, now it switches. My A and my B are going to be these two. So now it switches. This is a B. This is a C. And I can use the law of cosines once again to find that missing angle. So let's go ahead and use that formula. Cosine of C equals 30.2 squared plus 22.9 squared minus 14.7 squared. And it's all divided by 2 times 30.2 times 22.9. The hardest part about this entire process is just typing this big mess into the calculator and evaluating it to the right number. The rest of it's just kind of throwing numbers in a formula. If you did it correctly, you should have the cosine of C equals 0.8823. And if we take the inverse cosine, not sine, if we take inverse cosine of 0.8823, that leaves us with 28.1 degrees. So this angle over here would be 28.1 degrees. And lastly, if you wanted to find the third angle over there, this one, you could do the law of cosines one more time. If you really love the law of cosines, you can do that again. Here's your A, here's your B, and your C would be over here. Let's not waste that much time. You can just subtract it from 180, and if you do that correctly, you should get, I think it's about 46.9 degrees. So that's how you use the law of cosines to find a missing angle. You need all three sides and then find the missing angle. There's one more to do on your own. Go ahead and give that a shot. Pause the video and come back when you're done. And if you set it up correctly and solved it correctly, you should have gotten an answer of 76 degrees. And whatever method you choose, law of sines, law of cosines, you should have gotten 40 and 64 for the remaining two angles. So that's the law of cosines. Join us next time to find the area of a triangle.